Құрметті көрермендер, бүгін біз басқа Каспий деңгейінен 25 минут төмен ғылыми подкастымызды бастаймыз. Our guest today is Dr. Enobong Bassey. He is PhD in gas characterization engineering from Auckland University, New Zealand, right? And his research expertise includes the petroleum system analysis, well testing, reservoir characterization, petrophysics, and geological integration. So also design characterization of all this gas processing. He has served now as an assistant professor at the Coventry University. So welcome, Enobong. How are you?
Thank you very much.
Yeah, welcome to our university. Welcome to Attrao Oil and Gas University. So we will talk about today about design of the gas facilities. My first question for you, how do reservoir characteristics, such as the pressure, temperature, and etc., influence on design of the gas facilities?
Yes, in fact, reservoir pressure and temperature are very critical factors in the design of surface facilities in the oil and gas industry. In fact, not only pressure and temperature, there's also the composition of the reservoir fluid, which I'm going to add up when we are continuing in our discussion.
Gas content.
Yes. So if I look at, if we have a typical reservoir that has a very high pressure, normally you have to design equipment that are very strong, in fact thick wall equipment, so that it will be able to withstand the pressure when it gets onto the surface. And then also in terms of the separator, we have to make sure that we have a number of stages of separation so that we can actually complete the separation of the fluid when it gets onto the surface. It depends also on the type of fluid, which, as I have mentioned to you, if we have gas, we have to make sure that there's going to be a drop in the pressure when it gets to the surface. So the size of the separator is important. If it's liquid, we also have to make provision for gas that is going to come out of the system. And then if we have a low pressure system also, we also have to consider how are we going to produce it, because the pressure is going to be very weak to produce onto the surface. So that's when we have to look at installation of artificial lifts, gas lifts, ESPs, in order to boost the pressure to come onto the surface and then continue in the production. So those are the things that will normally affect or that we look at when we are designing surface equipment. Then if I go on to temperature, most of the reservoirs could be at elevated temperature or higher temperature. In that case, and so remember, as the fluid is unloading out of the reservoir onto the surface, there's going to be a drop in temperature. So there is a tendency for us to have hydrate forming as a result of the drop in temperature, and then there's a tendency for us to even have wax if there is a very sharp drop in temperature. That is a flow assurance issue. So all these are the things that we normally look at when we are designing surface equipment. So we normally have to consider all that. Then if I have to combine both the temperature and pressure, that's where volume comes in, where we have to do a detailed PVT analysis to make sure that whatsoever, yes. Now, in order for us to ensure that the surface equipment, the tanks, will be able to contain all the volume that is coming out onto the surface at the required time, and that the compressor, the pumps can, and then also the relief valves are able to contain whatsoever pressure or temperature or flow rates that we are producing onto the surface. So all these are normally very important when we look at the design of surface equipment.
Okay, thank you. So there is unconventional reservoirs and conventional one.
Yes.
Can you tell our spectators about the differences and what is also the key challenges in design for unconventional reservoirs?
Good. Most of the reservoirs that we've been working on have been what we characterize as conventional reservoir, where we normally have maybe water at the bottom of the aquifer, and then oil, and then gas at the top. But unconventional, is where you have tight formation or tar sands or tight sand formation or shale formation, as it's called in the US, or even coal bed methanes. These reservoirs have very, very peculiar characteristics in that most of them have very, very low permeability. So it's difficult for us to produce by its own energy. So in most cases, we will need to if I carry out some stimulation, in that we carry out hydraulic fracturing
to enhance penetration,
to enhance the permeability, and to help in the ease of flow. So that is also another challenge, in that we have to pump in some water in some cases, and then when you are producing also, remember that we are going to now produce oil and water onto the surface. So we have to make provision for the treatment of the water when it gets onto the surface, while at the same time we still separate oil from gas. So it is a challenge for the industry, but at the same time we look at the economics. As far as the the volume of oil that we produce is very economical, it is okay to do that investment. But unconventional comes in with another challenge, which it's not bad anyway, because as far as I said, as far as the economics is good, we still have to do the investments.
Okay, but this is also there are a lot of typical unconventional reservoirs in pre-Caspian basin. So this is also challenge we are facing. Okay, so concerning the life cycle, so how do changes in reservoir the dynamics during the exploitation the life cycle?
Any reservoir comes with its own life cycle. It's very peculiar. When it comes, we normally have a profile that it grows up to the peak and then it starts declining again. So, but most of the design of equipment are designed for the peak performance. We normally design equipment for the peak performance. But we also
working in waste in the beginning.
That is it. So when it gets to the peak, and then what happens? So most of the unconventional will have a very rapid decline at the end. But when we design, we have to make sure that it's very flexible enough so that if we have a modular system that we can easily modify in order to accommodate the changes. For remember, when we have the maximum production, so maybe, it depends on a typical reservoir. If I give you an example, most reservoirs will produce for effectively 10-15 years, optimally, and then after that you start experiencing a decline in production. But that decline in production is a decline in production of oil. But if we have to quantify the entire fluid that is coming out, there is always a large amount of water cuts, in that there is a substantial amount of water that is being produced, so we have to make provision for separation, then for water treatment and water disposal when we start experiencing that decline in the volume of oil that we produce. So all these are issues that we look at in terms of the surface equipment, for the separators, as I mentioned, the tanks, and the pressure vessels that we design, and the treatment facilities that we install at the surface. So, the decline is normally in terms of the volume of oil, but in terms of the volume of water, is normally an increase.
So that's like 50-60 years ago, during the oil gas production industrialization, no one cared about what's going on around.
No.
But now in 21st century, sustainability plays some role, so we have to keep in mind this problem. So what is the role of sustainability in design of the gas facilities?
Very good. In fact, the oil and gas industry has integrated sustainability in almost all aspects of the operation, from the upstream, midstream, down to the downstream sector. So, take for example, if I pick from the upstream now, most of the operations will require us to integrate carbon capture, so that whenever we produce, even I mean, the carbon dioxide that is produced along with the gas, we try to separate it and then maybe sequester it or reinject it or even use it for even enhanced oil recovery in some cases. So there is, you know, a drive to make sure that we improve the productivity and reduce the amount of waste. You know, waste management is also another issue in terms of sustainability, which I have mentioned. In fact, as I have mentioned in carbon capture, most of them integrate in fact carbon capture in the system. And then, as I have also mentioned, water production is also a major issue, which we have to treat the water effectively before we dispose of it. Another factor is biodiversity.
With full recycling and so on.
Yeah, full recycling. Full recycling, like, okay, most of the large fields, if it's offshore, in some cases, you look at even an offshore separator, okay, so that you don't even allow the water to produce onto the surface. Okay, it's separated at the seabed and then reinjected into the reservoir. That is a typical system, so that at the end we don't have any waste. It's only oil that is coming out onto the surface. I was just about to mention the issue of ecosystem maintenance and biodiversity. It's always important we look at the environment that we are operating. You know, how was it before we went in to exploit the resource there? And then how are we preparing to restore it back to close to where it was? It may not be 100%, but close to what it was before. So ecosystem and biodiversity management is particularly important when you get into start exploitation of resources. So all those things are what the oil and gas industry is doing. If I have time, maybe I just throw in the issue of hydrogen. You know, I mean, the oil and gas industry is looking at improvement of processes, so that if a hydrogen that normally would have come along with hydrogen sulfide, we try to process it and separate it in some cases, and then it's a good market now, you know, so that we try to decarbonize as much as possible and go towards net zero. Everybody wants to go towards net zero. Okay, so that is a plan now. So, I mean, the oil and gas industry is employing a lot of things in order to improve, I mean, the sustainability of the operation, as I mentioned, both environmental and then also in terms of community involvement. You need to talk to the community to make sure you assist building up the environment as it was or as it's going to be after you left the operation. So there are so many things that come into play.
Yeah, even so, if you have the source of hydrogen like
Yes.
this, so it's a very good way to mix them with CO2.
That is it.
Yeah,
Yeah.
because it's
Yeah.
this mixture is a very good organic,
Yeah.
the precursor
It is.
for
It is. And then, okay, if I may also mention that in fact now there is a plan to see even how to blend hydrogen with methane gas, so that we could even use it at
this
homes.
combination,
Yes.
for chemistry, yeah.
Yes.
Okay.
So it's a lot of things coming on, and the industry is not left behind. I mean, they're all involved in all this.
Okay, thank you. So we're recording our podcast just after the finishing the SPE conference,
Okay.
regional conference here in our university. That was the first time on Atrao,
Yeah.
first time in a university, and
Yeah.
we are lucky to
Yeah.
participate as a delegate. And of course, I would like to ask you about your personal opinion, what was going on the conference, and of course the how they can impact on our student and faculty in the future.
Definitely. In fact, I said I was lucky. I was fortunate, to be around Accra Oil and Gas University when the SPA Annual Regional Conference was holding. And fortunately, as I said, it's very rare before an SPA and Annual Technical Conference is held in a university. You know, but Accra Oil and Gas University is fortunate to be, one of the rare hosts of an annual technical event. And it was very successful. If I start from the quality of papers and the quality of presenters were excellent. I mean, from the opening ceremony through to the end, the attendance was excellent. Almost all the technical sessions were full, and engaging in discussion, in technical discussion. So it was very good. And as a university, I see this as a milestone in the university because it had demonstrated its capability to host such an event. In fact, from the rector to the key personnel, and other principal officers of the university, I mean, they were all involved in the organization, and the students were not left behind. I mean, in fact, they were involved, in making sure that everything went on very smoothly. So it was, in fact, I was proud of the university, what they have achieved.
Yeah, thank you.
Being able to host such an event, for a number of days, each free, and very successfully. So I see it as an encouragement. It shows the relationship that the university has with the industry. So, and I want to see the university more involved. Already it is involved in the industry. The stakeholders are interested in what the students are going through, in the quality of learning, in the quality of courses. So it is very important, that we see a continuous development. So I'm very happy. I'm really very excited.
Okay, thank you very much. Yeah, and so our last question, traditionally about the near future, like if we imagine what happened in the next 5 years, so looking forward, what do you think about the advancement in the sustainable design of the surface? The gas processing, or
very good, because I mean, as we know, the industry is very dynamic. I mean, there's always changes going on. It's important we integrate, in fact, most of the reservoir modeling with the production profile that we are having. So that is one of the major things that is going on, so that at the end, there is good improvements in technology that has been able to integrate both what happens at the reservoir, and from petrosciences, to reservoir simulation, to production management. When we have that integration in the system, it's very easy for us to predict how the reservoir is going to behave in future, and then plan adequately for surface operations.
What about artificial intelligence?
That's
We actually had some the section in SPE Congress as well.
Definitely. But that's where I'm going, because now most of what the industry is looking at is what's called digital twin. So that at the end, the system that you install on the surface, could actually be simulated, so that we can have a good history match of what happened previously, and then have a good predictive model of how it's going to behave in future. We can, as you said, what happens when they start declining? We can even have that simulation, in fact, before we have that experience of a reservoir declining, and then look at how much is going to be a water cut, how much is gas going to be produced, what size of separator do we require. We can simulate all those processes, so that at the end, it's not very expensive for the industry. And then AI is coming in. In fact, machine learning is being integrated into the system, so that you can have a good probability and prediction of how even each of the components,
how well equipment
how well equipment are going to behave. When are we going to require to replace a pump, a compressor? When are we going to require to maybe inject more of corrosion inhibitors in order to sustain the flow assurance? So all this have been well integrated, so that, I mean, the technology is there, and the industry is there. And then I'm happy that the manpower, the young people that, I've seen both here, and elsewhere, are embedding and are involved in the development of this technology. So I see a bright future for the oil and gas industry. I see a very bright future.
Okay, thank you, Professor. I sure you enjoy staying with us these months. So anyway, welcome anytime to our university.
Thank you.
We are very glad to see you here in Atrau. So and hoping to be in touch for in future for the oil and gas industries and making it better for our region.
Yeah, definitely have built up a lot of collaboration that I look forward to sustaining. So as I said, it's been a very successful couple of weeks. So I'm very happy. So I look forward to further collaboration. Thank you very much.
Yeah.
Thank you.
Құрметті көрермендер, біз келесі апта кездесеміз.